Hey AP Stat students, this is Mrs. L, and we are just 20 plus days away from your AP test. So I wanted to give you some tips and tricks and some notes about this AP test, especially as I was grading your free responses. I kind of took notes on some common mistakes I've noticed. And I also realized a few things when I was going through them that I didn't even know that readers, graders were looking for that I wanted to address here in this video, specifically for you guys. So yeah, I'm gonna attach this document on Google Classroom also, so feel free to print this out and follow along, or at least you'll have a hard copy with you for whenever you need. And you can even use it on the AP test because it's open book, open note. So use whatever you got. Okay, so the first thing I wanted to note, and I realized that I have to kind of remediate a bit, was when we do hypothesis tests and confidence intervals, there's a few things in here that I wanted to kind of address that I didn't teach you or that I need to specify more than what I did in class. All right, so I pulled out this problem. This was from one of the videos that I assigned, so hopefully it looks familiar to you. And I'm going to show you guys a few things that you want to adjust for the AP test. And I am pretty confident, like maybe 99% confident, that an inference test, a hypothesis test, or a confidence interval will show up on this year's AP test. So I want to make sure you guys get as many points as possible. Okay, so I'm just going to do this, and I'm going to kind of highlight what I want to remediate for you. Okay, so let me just kind of reread the problem first, and that way it's fresh in your mind. All right. So it says, a large university provides housing for 10% of its graduate students to live on campus. The university's housing office thinks that the percentage of graduate students looking for housing on campus may be more than 10%. All right, so I'm going to start highlighting these things. More than 10% is what they're thinking. The housing office decides to survey a random sample. All right, so that's good to know, of graduate students, and 62 out of the 480 respondents said that they're looking for housing on campus. All right, so I know, that P hat is equal to 62 out of 481. And this is what I like to do. I like to pull out kind of the more important information pieces as I'm reading through the problem. And that's the very first thing you should always do, is just read the problem very carefully before you even start working on the question. All right, so part A, it says, on the basis of the survey data, all right, so based off of this P hat, would you recommend that the housing officer consider increasing the amount of housing on campus available to graduate students? Give appropriate evidence to support your recommendation. All right, so this is asking us to do a hypothesis test. All right, so they're just trying to figure out if the housing percent for graduate students is more than 10%. So this, since we're talking about percentages and proportions, this is going to be a 1 proportion Z test. All right, so let's start with our first step, which is always to set up our null and alternative hypothesis. So I'll start there. And we have P, we want to see if that's greater than 0.10, meaning our null hypothesis is always the equal sign version of that. Okay, so in class, I would just have you guys stop there, and that would be it for step 1. Actually, what they're looking for and what readers are starting to look for is that you define your parameter of interest. So you actually have to write out what P is in the context of the problem. All right, so I'm going to go ahead and do that on the side here. So P, and you can just use the wording from the problem itself too, in this case, would be the population proportion of grad students who prefer living on campus. All right, so that is the first note I want to give you guys, is that they are looking for you to define that parameter of interest in your step one when you're setting up the null and alternative. If it was means, then you would talk about the population mean instead of proportion, and if it was like a 2 sample, then you would have to define both, right? So just be careful on that. Okay? All right, the next step we know is that we need to do our conditions. So let's go ahead and do our conditions here. And for one prop Z test, conditions, the first thing is we're going to check to see if it's a random sample. And in this case, I already highlighted up there that it is a random sample. So I'm going to say that data or the sample was taken randomly. And I mean, I think it's a good idea to just kind of state that as a complete sentence. It just shows thoroughness and clarity of communication, and readers, stats readers really like that. They can sniff out somebody who's just kind of being lazy and just writing random sample, check mark, and I think that kind of might like push buttons on some readers. So again, the more clear and the more thorough you are in your explanation, the better chance you get for more points. So I'm going to just use a complete sentence. So the sample was taken randomly. There you go. All right, and then our second condition, because it's proportion, I'm going to check my NP and Q, making sure both are greater than or equal to 10. I really like that no one's really using CLT when it comes to this, because it's not means. Remember, CLT and being greater than 30 is only for means. So looking through your work, guys, good job on differentiating when you can use CLT and when you should use NP and Q. All right, so in this case, we have NP. All right, this is 481.10, so this is 480.1, greater than 10, and do make sure you show that it is greater than 10. And Q, and yes, you do have to show both. Okay, is greater than 10. Sorry, my handwriting is so bad on this thing. Okay, and let me just double check. I'm pretty sure I got that number wrong. Oh, no, that is right. Okay, cool. All right, so that's same as usual. Okay, everything's fine. This, I don't think you actually even have to show, so you can omit that, and that's fine. Really, they just want to see these two pieces. Okay, now there is actually a third condition. So for those of you guys who have checked your homework, your free response, and saw that you got docked points for one of our last assignments, the reason why is because there's this third condition that I never taught you. The reason why I never taught you was because they haven't checked this condition in many, many, many years. And so I just took it off because the AP readers never checked it anyway. But this year they decided to start checking it again. So this condition is called the 10% condition. All right, I think I wrote about it up here. Yeah. So that first bullet point, it says check 10% condition if sampling without replacement. This is a test for independence. All right, so if you know that your sample is sampling without replacement, all right, if you're sampling too much of the population, it actually affects the makeup of the population. And so your sampling actually affects what's happening, and the proportion is like changing. So we want to check to see if our sample is less than 10% of the population. All right, so that's the condition, that our sample size is less than 10% of the population. All right, so let me show you how to check that down here. Okay. And you can do this in many ways. The way that one of these video guys that I've been assigning does it is he wants to check to see if the population is basically greater than 10 times your sample size n. All right. And so since we don't know the population size, we just have to see if it's reasonable to assume that. So in this case, our population, we want to see if it's reasonable that this population is greater than 4,810. All right, and so you want to go ahead and write a statement about, it's reasonable to assume the population of all grad students is greater than 4,810. Okay. So hopefully that makes sense. I think in some of the other videos that I've assigned, they've shown this a few more times too. So hopefully you guys have seen a few more examples of this with those assigned videos to kind of get a good idea. But this is basically it. All right, so that is the 10% condition. Make sure you check that. All right. And then step 3 is our statement. So I will use a normal model to do a 1 proportion z test. Now you guys might have not noticed, or you might have noticed that some of these video guys, they don't make that statement. The reason why I have you guys do that is because if you name the test, then you don't actually have to show the formula in the next step when you do calculations. So I think naming the test is way easier than using the formula, having to make sure to plug in the right numbers. So that's why I have you guys do this step. Okay. All right, let's go on to calculation. So this is same old, same old. You guys will plug the stuff into your calculator. You would find 1 prop z-test on your calculator, and you just want to report your test statistic, in this case, 2.11, and your p-value of 0.0173. Okay? All right, and then lastly, your conclusion. Not much to change about your conclusion. You guys all do pretty good on this one. The only thing I want to note is that typically I had you guys say something like, since the p-value is so low, I reject the null hypothesis, and then there is enough evidence to suggest that the population proportion of grad students who prefer to live on campus is greater than 10%. All right. So that is pretty much what we've done in class. There's one thing I do want you guys to change just to make sure you guys get full credit. it says at the very top, since the p-value is so low, I'm going to have you guys adjust that to since the p-value is less than alpha of 0.05. I think they want you to be more specific in terms of comparing it to that significance level. So instead of saying since the p-value is so low or so high, say since the p-value is less than alpha or since the p-value is greater than alpha. So be more specific there, and that way I want to make sure you guys get max points there. The last tip for this one I would have is to go back, and this goes for all types of questions, just make sure you answer the question. It says, based on the basis, of the survey data, would you recommend that the housing office consider increasing the amount of housing on campus available to grad students? All right, so I actually did not answer that question yet, so I would probably get marked off even if I just had all this work. So in the end, I do want to make sure I answer that question and say, yeah, there is evidence that there's more than 10%. So I would say, what was the question again? Yes, I would recommend that the housing office consider increasing the amount. All right, so then answering that question, yes, I would recommend increasing housing for grad students. All right, so that's a tip. Very, very strongly recommend you guys always, once you're done, go back, reread the prompt, and make sure you answer all parts of the questions. AP Stats problems notoriously have multiple parts, so make sure you've answered every single part. Okay, so I think that is everything in that first bullet point. Going on to the next. All right, my next piece of advice for this AP test is make sure you guys show work. A lot of you I know can do things in your head or do things on your calculator, but no matter how simple it is, or even if you're filling out numbers in a table, if there is a step, like a number, like a proportion, this divided by this, show that work, because it really sucks to lose out on half the points just because you didn't show your work. So please, please, please make sure you do that. I had to mark some people down already on homework just because, yeah, they didn't show enough work. All right, next, read the prompts carefully. I kind of already touched upon that, but that's very, very important. So if there's a yes/no question, make sure you say very clearly yes or no, and then justify your answer. If it says to use an answer in a previous part, make sure you use the answer you got on that previous part as part of your justification. So I wrote that because I noticed that a lot of you guys didn't do that when it came to certain problems. So for example, there was one problem on your homework that it said, based on your answer to part C, would it be surprising, ... And a lot of you did not use part C. You just kind of answered the question in part D and didn't even look at part C. So make sure that if they're asking you to use a previous part, use the previous part in your answer. All right, and I think this right here was that homework problem. I think it had like a scatter plot of some sort, and it was talking about like foot length and height. And part C said, the following histogram summarizes the 65 residuals, and assume that the distribution of residuals is approximately normal with a mean of 0, standard deviation of 5.9. What percent of the residuals are greater than 8 centimeters? Justify your answer. All right, so I'm just going to do this real quick. All right, so then I would say, normal CDF. I want greater than 8 centimeters. So 8, big number. Okay, mean of 0, standard deviation of 5.9. I'm going to mark this as lower, upper, mean, and standard deviation. And let me grab my calculator. And I get about 0.088. Okay, so 0.088. All right, and then that would be my part C. If I was doing this on an AP test, I would write a sentence about that, it said, and say that again, like the percent of residuals greater than 8 centimeters is 8.8%. All right, and that would be part C. Now for part D, it says, based on your answer to part C, would it be surprising to randomly select a high school senior from the high school with a foot length of 20 centimeters and a height greater than 165 centimeters? Justify your answer. A lot of you guys just answered this kind of on its own, and you didn't use this 8.8 at all. And so a lot of people got this wrong because they didn't use that residual. So the right way to do this problem would, to find that residual for the length of, foot length of 20 centimeters. And I think what happened was when x was 20 centimeters, the predicted height ended up being about 157.06. So then the residual was the actual minus the predicted, being about 8. All right. So that was no coincidence that the residual was approximately 8 centimeters. And so that's how it connects to part C. All right, and so that means that we'd expect about 8.8% of all high schoolers, school seniors, with a foot length of, room, 20 centimeters to be at least 165 feet tall. So this is not surprising to answer the question. So, I mean, you can say that you thought that it is surprising because 8.8 seems low to you. Or if you thought, oh, 8.8 is not too bad, then it's not surprising. So it actually didn't really matter if you said it's not surprising or if it is surprising, but you do have to state whether or not you thought it would be surprising, and then use the number you got in part C to justify that. Okay? So yeah, just be careful if it says based on your answer in part A or B, make sure you use those numbers. In the same way, if it says something like, based on the graph of the simulation, make sure you refer to the graph in your justification. All right, so don't just go off of anything else. Make sure that your basis of your justification is on whatever they're stating. Okay? Okay, let's go down to our next point. All right, so next point I have here is don't feel like you have to use fancy statistics lingo to get a higher score. All right, that's just not true. When the readers look at that, they can tell that you're just, throwing vocab terms out. And if you're not using the vocab terms correctly, it's really obvious. So make sure you are just being as precise, clear, and thorough in your explanations. So if you have to just use everyday language because, that's what makes what you're trying to say more clear, use everyday language. You don't get bonus points for, trying to impress them with big vocabulary. All right. Next one, writing out calculation commands. So like normal CDF, binom, inverse norm, etc. Make sure you label the inputs. This year, to make the test more equitable, I don't think it's going to be, calculator heavy, but just in case you do need to use your calculator, make sure you input or you label all your inputs. So for example, let me quickly go through some of them. Normal CDF, make sure you label your lower bound, upper bound, mean, standard deviation. And be careful about these subscripts. Sometimes it's X, if it's just, or if it's just population, you won't have X, you'll just have mu and sigma. Sometimes if it's a sample lean distribution, you could have mu sub X bar, sigma sub X bar, or p hats. Okay, or you might even have the difference between proportions. So just be intentional. And honestly, if you are just not sure about the notation and you are maybe strapped for time, just write mean and standard deviation. All right. So just keep it generic, and that way you don't get docked for having wrong notation, but you are still labeling it. All right, and then with binom, PDF or CDF, I'll just write PDF here. It's N, P, and X. For geom, met, it's just P and X. Inverse norm, you have area to the left, and then mean, standard deviation. Okay. All right. So that is it for calculations. Let me see what else I got here. Okay. All right. So the next thing I want to talk about is just kind of, after grading your FRQs, I noticed that the handwritten responses that I've gotten have been on average a lot more thorough and precise, especially with, showing work, graphing, labeling. So if I were to take this A/B test, I would definitely take this on paper and take pictures to upload it. On Monday, May 4th, they're going to do a demo, or they're going to have a demo available for you guys to kind of practice that. So I would just practice the different ways of uploading the test and just kind of see what you're more comfortable with. But I have noticed that when you guys are typing out your responses, you're just not doing as well because you're not being as thorough, and you are kind of, not labeling as much and not showing work as much. So that would just be my advice. All right, my next point, they've updated the formula sheet. So it's actually a lot better. I really like it a lot better. And I would just print one out and get familiar with it because you can definitely use that on the AP test. All right, next, once you have finished your answer, reread the question and then read your answer to make sure it answers the prompt. All right, I think I already talked about that. And just double check you answer all parts of the question. Okay, so I'm like really emphasizing that because I think I've just seen that so many times. One of the things I noticed that a lot of you guys miss out on is when it says calculate and interpret. A lot of you will just calculate and then you do not interpret. And I would say even if it didn't say interpret, you should still interpret it anyway, because a lot of times these scoring rubrics will ask, will be looking for context. Even though the problem doesn't say anything about it, the reader will still be looking for it. So just always calculate and interpret. Okay, so for example, this one right here, I think this was a homework problem also. It says calculate and interpret the residual for high school seniors with a foot length of 20 centimeters, height of 160 centimeters. I think half of you forgot to interpret. Okay, so let me show you how I would do this. This is a, let me see, let me pull out what we need. Okay, so this is our y-intercept. This is our slope. This is our x variable, so our height is our y variable. So then we have predicted height is equal to 2.599 times the foot length plus that. Alright, so let me pull out my calculator, plug that in. Alright, so I'm going to plug in 20 centimeters for foot length, and I get 157.06. Oh, I think this is from the same problem as before. Alright, and then we have an actual height of 160. So the residual would be your actual minus your predicted, which gives us 2.94. Alright, so a lot of you, I think almost all of you, got that answer, but then you moved on. And so you did not get full credit on this. So make sure you interpret that and you state that the high school senior with foot length of 20 centimeters was 2.94 centimeters taller. Okay, make sure you specify it's taller than the line predicted, or that the model predicted, or that we predicted. Okay, so make sure you interpret. All right, moving on. Next point right here, we have read the problem carefully first before going into the question prompts. All right, and I think I already talked about that. It's more important that you guys take the time to really read through what the question is asking, especially I would say for these for this year, since there's only 2 questions and there's probably going to be a lot of parts. It's important that you really understand the question before moving forward. All right, my next point, describing the distribution. I think you guys are getting confused about the directions about describing the distribution versus describing specifically the shape of the distribution. So when you're talking about, let's say, like a histogram, make sure that when you describe the distribution, you use SMUX. And actually, you don't really even need the M, apparently. The video guys haven't been doing the mode, so you can just do SUX. For describe the distribution as a whole. And when it specifically says describe the shape, it's just talking about the S part of SMUX. All right, so it's just talking about symmetry. Is it approximately normal? Okay, so just be careful when they ask you to describe the distribution. Make sure you do symmetry, unusual features, center, and spread. If it just says describe the shape, you only have to talk about the symmetry. All right, and then I think this is our last point. When asked to calculate a value, make sure you show work, write your answer, and then explain what your value means in the context of the problem. I think most of you guys are doing 1 and 2, but a lot of you guys are missing points because you're not doing part 3. So put your final numerical answer in a sentence and in context. And a lot of times you can just rewrite the question prompt with your answer plugged in. All right, so let me show you what I mean. All right, so this was, again, another homework problem you guys hopefully remember. It says, the distribution of pH levels for all community swimming pools in a large county is approximately normal. All right, so I'm going to highlight that. And that's good to know. With a mean of 7.5 and a standard deviation of 0.2. All right, so that is our population. According to swimming pool studies, safest pH levels for water swimming pools are between 7.2 and 7.8. One community swimming pool in the county will be selected at random. Okay, so just choosing one. What is the probability that the selected pool has a pH level that is not considered safe? So not considered safe. All right, so what I would do here is I would, it already says it's approximately normal, so I don't really have to check conditions there. So I would go ahead and just find out the probability that it is safe. So going from 7.2 to 7.8 with a mean of 7.5, standard deviation of 0.2. This is lower bound, upper bound, mean, mean, and standard deviation. And I would do the complement of that. So 1 minus that would be when it's not safe. All right, so let me plug that in real quick. And I have normal CDF, 7.2, 7.8, 7.5, and 0.2. And I get 1 minus 0.86639. And 1 minus that, I get 0.1336. Okay, so that is my probability that it is not safe. Now, again, a lot of you guys got that answer correct, but instead of getting E, you got a P. And the only reason why is because you did not have any context in your solution. So to solve that problem, I am literally just going to copy that last sentence, but I'm going to put my answer in. So I'm going to say the probability that the selected pool has a pH level. I'm so sorry, my handwriting is terrible on this. That is not considered safe is, and just write your answer in right there, and now you got an E. Okay? So anytime you guys have just a numerical answer, just rewrite it in a sentence with context just to make sure that you get full points for that. Alright, well, hopefully you guys will be able to use these tips and notes on your AP test and maximize points on that AP exam coming up. Alright, as always, if you guys have any questions, please feel free to email me. Alright, good luck!